Finding the area of a regular polygon. So let's first talk about the formula and what you need for the formula. So here it is. Area equals 1/2 the apothem times the perimeter. So remember, this is not, that doesn't mean area, that doesn't mean altitude. That A means apothem, and this P means perimeter. So apothem times perimeter. So let's think about what that means. The apothem we know to be from the center, right? We know that, and we know it goes straight down to one of the sides and creates a right angle. So that's my apothem. The perimeter of a figure, remember, is the sum of all of the outside edges. So I'm going to take all of these edges, right? And I'm going to find all of their lengths. I'm going to go all the way around, and that's going to be my perimeter. I'm going to add them up, each side length. Okay, so let's jump in and try one. This first example is easy because most of the information is given to us. So it says, find the area of a regular decagon with a 12.3 apothem and 8 inches on the sides. So here's the problem. You need to know what a decagon is. How many sides in a decagon? I hope you said 10. We have a 12.3 apothem and 8 inches on every side. So I like to label my pictures because I'm kind of crazy like that. So 8, 8, 8, all the way around 8, right? How many 8s will I have? Well, it depends on how many sides in the figure you have. So there are my 8s on each side, and then here's my apothem. It forms a right angle with one of the sides, and they told me it was 12.3 inches. Okay, 12.3 inch apothem and 8 inch sides. Now, I have to first think about area equals apothem times perimeter. So then I go, what do I have? Let's plug into my formula what's given. Well, my apothem is given, so I'm going to plug that in. Area equals 12.3. What's my perimeter? Well, I don't necessarily have the perimeter given to me in specific numbers, but I can find it, right? So you find the perimeter by adding up the side lengths. So perimeter equals adding sides. Okay, I don't want to do 8 plus 8 plus 8 plus 8 plus 8 plus 8 10 times because there are 10 sides. So I'm going to do this the easy way. I'm going to say that my perimeter is equal to 8 inch sides, and I'm going to multiply that by 10 because there are 10 sides. Instead of saying 8 plus 8 plus 8 plus 8 plus 8 10 times, I'm going to do this the easy way. So there's 8 and there are 10 of them. So the perimeter is equal to 80 inches. Now I have what I need, and I can plug it in. And so the area of this regular polygon is 492 inches squared. That problem was relatively easy in that they gave us everything. We didn't have to really solve for any missing lengths. Here's the problem with 99% of these regular polygons, is that they do not give us all the information. We have to find it. So let's scroll the page up. We're going to bring back our special right triangles. It says use properties of special right triangles to find the area of these regular polygons. So let's do that. Let me scroll this up just a tad more. Okay. So get this out of your way. Put it down here for now. All right. So let's first label what you need to know about this figure. Okay. So what's given to you in this figure? Here's what you have. So we're going to put the center in, and this is a 10 millimeter length side. Okay, this is a 60-degree angle in here. Okay, and the apothem is drawn in, and we are told we don't know what it is. It's just A. And I do know that this is 5. That little segment right there is 5. So this is all I know about my figure, all right? So first let's just try to figure out, is there any part of the formula that we need to know? So I always just jot my formula over here, and then I do the steps and the things that I need to search for sort of off to the side. So do I know the perimeter off the top of my head? No, I have to find the perimeter, so let's do that. So I have a how many sided figure, so let's check. 1, 2, 3, 4, 5, 6 sided figure. So 6 sides times the side length, which is 10. So number of sides and side length. All right, so I do that part first. Perimeter equals 60. Good? So I can do area equals 1/2, and I can put 60 in here for my perimeter. Okay, now I have to find the apothem. So step number 2 means that I now have to search for this apothem, and here's my triangle. So I have to do some special right triangle figuring, right? I know this bottom length here is 5. That was given to me. And if I know that this entire angle is 60, then I know that this is going to be half of 60, or 30. And then what that tells me is that here's a 90-degree angle, here's a 30-degree angle, so this has to be a 60-degree angle. So I have a 30, 60, 90 triangle, and I have to solve for my missing side. So let's label our 30, 60, 90 triangle. Across from the 30 is n. The hypotenuse is equal to 2n, and this third side that I need to have is n square roots of 3. So this is a nice and easy one in that I already know what n is. N is 5, so I can plug it in, and my apothem is 5 square roots of 3. Again, I would encourage you to change that decimally just for now and make this a little bit easier. So square root of 3 times 5 is approximately 8.7. Okay? Usually to the nearest tenth. So there's my apothem, so I can plug that in to my formula, 8.7. And now I have everything I need. Area equals 1/2 8.7 times 60. 8.7 times 60 gave me about 522. And then when I do half of that, I get 261. And this was done in millimeters. Area is always squared. There's my label. So you'll notice when I do this, every time, and this might be handy for you too, I put my formula here and sort of get it ready to plug in what I need to plug in. And then off to the side, I do my steps. Step 1, find the perimeter. Step 2, find the apothem. And I use my triangle to find my apothem. So if you do your steps off to the side like that, it should be handy for you. All right, let's try the second example. This is a pentagon, so 5-sided figure. Let me show you what's given to you for information. Here's what you have to start this problem. So we tell you that this segment is 6.1 and that this segment down here is 7.2. And that's all we tell you. So you don't know the apothem, and you also, we didn't tell you essentially what the perimeter is. You have to figure it out. All right, let's do the problem using those steps that we were talking about a few minutes ago. So write down your formula. Area equals 1/2 apothem times perimeter. And then let's go over here and start with finding my perimeter. So again, perimeter is the number of sides times the side length. Okay? That's how you find perimeter. So, perimeter equals number of sides, 1, 2, 3, 4, 5. 5 sides. So I have 5 sides, and each side is 7.2 in length, which gives me a perimeter of 36. Okay? So, area equals 1/2. Put my 36 in here for perimeter. Step 2, find the apothem. So I'm going to redraw the triangle. That's the apothem I'm looking for, right? So here's the deal. I got to figure out how long this piece is. So if the total is 7.2, this is going to be 1/2 of that full length 7.2. Half of 7.2 is 3.6. Okay, so let's label that over here. 3.6. Fantastic. I'm looking for my apothem. And if this segment here is 6.1, then this one has to also be 6.1. So I'm going to put it here, 6.1. All right. My other question for you is, what are my angles? Is this a 45, 45, 90? Is this a 30, 60, 90? How do I figure this out? So we got to figure out what our angle measures are. Or do we? We did in this problem. We had to, because we had only one side length. But look at this one. We have two side lengths, and we're just missing one. So I point this out to you because sometimes you're going to use your 30, 60, 90 information. Sometimes you're going to use the Pythagorean theorem. Why would we use Pythagorean theorem in this case? Well, I have no angle measure information. I would have to break up my pentagon and see if I could get a 30, 60, 90 or a 45, 45, 90. But since I have two sides and I'm just missing one, I can use Pythagorean theorem. All right, so be thinking about, why would you use Pythagorean theorem? Why would you use 30, 60, 90? If you know you have a special right triangle, use those because they're easier. But there are cases where you will use Pythagorean theorem, like in this case. So my hypotenuse is 6.1, and I have a squared plus the 3.6 squared, right? 6.1 squared is 37.21. A squared. And then here I get 12.96, and then I have to, of course, subtract that from both sides to get the a squared by itself. So a squared equals 37.21 subtract 12.96 is 24.25, and then again, how do you undo a perfect square? You square root it. So we're going to square root both sides, and when we do, we get a equals about 4.9. So now I have my apothem. Put it in. Area equals about 88.2, and I didn't give you a measurement, so you don't need to worry about labeling it if there's no measurement. All right, so we used 30, 60, 90 here because we were given that that's a 30-degree angle, and we were able to figure out the rest. We used Pythagorean theorem here because we had two of the side lengths and we were just missing one, so that's easy to plug in, and we get what we need.